Hello everyone, welcome back to Deep Agents learning series. So till now we have seen how we can create agents, how we can create backends. Now the next topic that we are going to cover is memory and skills. So these two are very important topic. So what is memory? Memory allow agents to remember things across conversation. And it is not just one conversation, it can be single conversation history or it can be multi conversation history. So earlier, when we used to build LLM applications like chatbot, we used to pass history, like last 10 history, conversation history, so that LLM can understand the context. But agents are much more sophisticated and we do not have to pass memory explicitly, but we have to configure our agents to use the memory in a smarter way. So memory can be of different types. Memory can be agent scoped, memory can be user scoped, memory can be long term, short term, episodic. It depends upon your configuration. So agent scope memory means every user shares the same memory. So the agents build a persistent memory layer. So let's say there are 10 users, all the users are going to access that memory and going to write back as well. However, user scope memory means user A have its memory, user B had its separate memory, user A cannot access user B memory and vice versa. So this is basically scope. Long-term, short-term memory can be like uh, a memory present in a current conversation is going to be a short-term memory. Long-term memory, if we are persisting a memory to a particular location, and again we are loading into cross conversation, like same user is creating a new conversation and he should have access to its previous memory as well. Let's say he is saving some information like location or work detail. So next time when it is going to ask some question, it is going to access that memory. So that is long-term memory. Now, next thing is skills. So skills allow or gives agents a capability to understand some domain specific task. Okay. And skills are called progressive disclosure. So progressive disclosure means when we create skills, we generally create a file which has name and description and its body. So whenever you are loading or whenever agents is starting, it will load all the skills description only, not the body. So that it will have a bank of all the skills where it can or it will have all the skills description, and whenever the user is asking something and LLM or agents thinks that we already have such kinds of skill, then it is going to load the complete body to understand how to use that skills. So that's why it is called progressive disclosure. It can have other things as well. It can have like assets, it can have references, some scripts. So how we create skills? So for to create skills, we create a folder, and in that folder we can have multiple folders for each skills, and we create a skills.md file. So our agent will understand, okay, these are the skills file, and to load that skill, whenever we are going to create this agent, we have to pass a skills parameter. Likewise, for memory also we have to pass memory parameter. For skills also we have to pass a skills parameter. By default, it is going to be empty. It means there's no skills present. But if we are creating a skills, to load that skills, we have to pass that parameter. Let's start with some demo and try to implement some code and try to understand some code so that you can understand how to implement memory, how to use memory, how to apply permission on that, how to use skills, and how to combine these two concepts together. So let's start. Okay, so here is I have created multiple demos here. So one demo I'll be sharing user scope and agent scope memory. So I'll tell you what I'm doing, and this is expansion of our existing code base. I'm using here in store memory. I'm not persisting anything. Make agent. This is a helper function that creates an agent. So I have added documentation here as well for your reference. So I'm creating an agent model. I'm using Google Gemini. Backend again. I'm using a store backend and store backend. In store I'm passing in memory store, and namespace I'm passing user id uid. User id will be passed as a parameter. It can be any id. Here for separation on the user level I'm passing user id, and I've given one system prompt. So since it is in memory, it is not going to write anywhere on the file. You can change backend if you want to store it in particular location. You can change backend, but here I'm using in memory. Now what I'm doing here we have two users, and for each user, I'm saving user's preference using separate agent. And after that, I'll create another agent that will lead. After that, I'll be creating another agent that is going to read that preference. Okay. So what I'm doing here, make agent. One user is Bob, one is Eli. And here I'm saving its preference. Its preference is dark mode. Here the second user preference is light mode. Again, I'll create a new user. I'll try to fetch the memory for each user. Okay. So let's run this program. Yeah. So demos. So here I'm saving the preference in a store in memory. Okay. Preference is saved for both users. Now it will create another agent and it will try to load the preference. Okay. New session. What do you remember about me? First user is asking, and it should tell about this preference. Remember this in memory. I prefer dark mode. So it should come here. Okay. Based on your memory file, you have the following preference. You prefer dark mode. You write all your code in Python. Okay. I write all code in Python. Now again, it is checking for second user. New session. What do you remember about me? Okay. So here you prefer light mode. You write all code in TypeScript. So here the memory is separated on user level. Each user has its own memory. Okay. Now the second one is agent scope. As I mentioned, let me clear it. Okay. Again, here, let me explain the code. So again, code base is same. Only thing here, I'm using assistant ID instead of user ID. Okay. I'm passing assistant ID. And what I'm saying, storage again in memory, everything is same. Okay. Same helper function. But now instead of user ID, it would be assistant ID, and same assistant ID will be passed for both the user. Okay. So since our namespace is same, see, this is just a matter of how you are maintaining the IDs. So here I'm using assistant ID and the same assistant ID will be passed to second user as well. So let me try. So first user I found, okay, maybe let me explain the code first. So what I'm doing, so I have created two users and one user has found some issue in the code and that user has also suggested some workaround. Now, second user is asking same question. So LLM or agent will able to find the memory about the first user that what was the workaround suggested by the first user, and it will tell how to fix it. So here you can see user one reporting a bug plus workaround. So here is the information that is going to be part of memory. User one has given workaround. Now second user is again asking my CSV export is crashing. Do you know anything about it? Okay. Since assistant ID is going to be same, so multiple agents is going to use same memory, and it would be like agent scoped memory. So you can see, yes, there is a known issue that export button. So you can see here, and it has also given the workaround that was suggested by first user. So same memory got shared across multiple users. So this is agent scope memory. And again, I'm telling you how we are maintaining agent scope memory. We are maintaining same ID. Okay? We are maintaining same ID and we are passing same ID to different users. Okay. Okay. So this is one example of skills. So I have created one skills folder. I have written two skills here. Let's check anyone here. So let's see skills.md for commit message style. Okay. Uh, Let me change the format here. Uh, okay. See, so first, this is the way we write it. So we have a skills name and its description. So whenever agent will load, it will going to scan this skills folder and it will load only name and description, mostly description. Description is going to tell whenever there's a relevant task, agent can understand which skills to execute. You can see we have other things as well, like commit message style. It can be anything. Basically, it can be anything. We have description and then its body. Description tells what this skills is going to do, and its body is how its body tells how that is going to be done. So it has multiple instruction how to do that. We have another skills as well. I have written one another skill that is text util. So if you see, we have skills as well. So again, we have description for text utils, and it has some instruction. So you can go through the instruction, you can pause the video, you can go through the instruction. Mostly it is saying that it is counting the line and then how it is going to print that. So see here we have a reference as well. So I have some other information in the reference folder. So if you see the reference folder, which I'm referring here, it has output format. So output format is telling how we are going to print the matrix. Okay. Now let's run this skill. Okay. So again, I'm using the same pattern. Here I have created a skills folder. So a skills folder is going to tell our agent where that skill is present. Okay, so I'm creating file system backend. Why file system backend? Because I'm going to use, or agent is going to use some file system. So that's why file system backend. Virtual mode is true. Skills is root. So I cannot directly pass. Uh, so I cannot directly pass the path of this folder. Reason is that I'm using virtual mode true. So when I'm using virtual mode true, agent is going to consider that directory, this skills directory as a root directory. And from here only, it is going to traverse because virtual mode is true and it is not, it cannot go beyond this directory. So that's why I'm using root here. If system prompt, just a simple prompt, system prompt. Now, if you see what currently I'm doing here or what I have written here as an instruction, so write a commit message for this change. This is a dummy commit message. For this, it is going to use the skills and it is going to use the format that is written here. So commit message skills, you can see I have some format defined like how to write this. So it is going to, it should write this in this way. Second is I need to extract word line character count from this text file. So again, now it should use this text util and then it should use the formatting instruction as well. So let's run it. Okay, let me clear it first. Okay, so you can see the commit message it has written is in the same format that this skill is saying. You can see the skill is this one. Skill says type, scope, imperative summary, lowercase, no trailing period. So you can see there's a no trailing period here, okay? And then some description. Here is one example as well at the bottom. So here is one example. So in the same way it has written. Second one, if you see the instruction, I need to extract word line character count for a text file. Now, which script should I run? I'm not asking to run it. I'm just saying which script it is going to use. And it has given me the script that it is going to use, this one. You should run the Python script located at this location and how it should be printed. So here, if you see, I'm not using the skills name anywhere. Based on the instruction, whatever instruction I am giving, it is automatically deciding which skills to use. And this skill is present in the skills folder, which is already part of agent skill object. So this is how it is loading skills on demand. So hope clear. Okay. So coming back to the skills structure. So at startup, we only load name and description. So name and description is going to tell what that skills is going to do and when it's needed. So at that point of time, we are going to load, or agent is going to load full skills.md body, and then any reference file that is being used in the skills. So again, this is the folder, how we should write skills. We have already seen it, that we should have a skill folder, and then we can have skills name, and skills.md is important, and then some scripts, some reference file. And while creating an agent, we have to pass that skills folder. Okay, so next example is how we can use skills. In the last example, we have seen that we are not executing any scripts, but we can also execute some custom scripts using skills. So in this example, we are going to see how we can execute some custom scripts. We are again going to use this text util, which is going to execute custom script. So you can see I've created one sample path. which is going to write some text file. So this is the text file I'm writing here, and I'm creating one agent, and I have given it local shell backend. So if you remember in my last video, I have explained you about file system backend and local shell backend. So file system backend can read the file, whereas local shell backend can execute custom commands as well. So here I'm creating local shell backend. Root dir is the again the directory that is I'm configuring on the top. It is same. It is going to be workspace directory and the root directory. Virtual mode is true. Since virtual mode is true, it is going to, we have to pass skills as a from that folder only. We cannot give a complete path here. And interrupt on, I have configured some interrupt. So you can also configure interrupt where human in loop is needed. So I have configured interrupt, and execute is true. Whenever it is going to execute something, it should interrupt. And whenever you are interrupting or whenever you are configuring interrupt, you should always give check pointers. So here I am not configuring any file-based check pointers. I am using in-memory saver. So, and the system prompt is you are a developer, and some basic system prompt. And here you can see I'm creating some formatting, and then I'm invoking the agent. So I'm invoking the agent with the instruction to count the numbers of word present in the file. That file I have just now created here. Okay. And here I have created interrupt. For demo purpose, I have given it auto approve, but every time it is going to approve, it is also going to print the log. So let's run it. Let me again clear it. So here you can see it has created a workspace, and in workspace we have this sample text. So here you can see our agent is running some commands, and it is also logging what are the commands it is running. Auto approve, I'm already using auto approve, so it is not asking for any permission, assuming that it is auto approved. And it has given here the output. What is the output? But one important thing is why it has executed so many commands. So I'll tell you what is the issue here. So first, agent tries to execute this command. So when you use virtual mode, agent cannot go beyond that folder here. Create agent, where is created? This one. So if I'm using virtual mode, our agent cannot go beyond that folder. But any command, that Python command or any script, it can go or it can access any folder. So that is one difference. So here what happens, Python 3, it is running from root, and it was not able to find this file because this is absolute path. It is not related to this virtual mode or the root directory. Since it is a shell command, it can execute from root. So it was not able to find any file or folder with this name. So that's why it had checked the PWD. Now agent is automatically taking the decision that what is the next command it is going to run. So it has executed PWD, and then it has executed this one, and it was not able to find it. Then it has forward slash, that is the root directory, and then it tries to find that file, and it was able to find it. Then it tries to find this sample.txt, again it was able to find it. So then it has created this correct command, and it has removed this root directory, and it has tried to run this command, and it was able to get the result. So this is how agent can make dynamic decisions, and it can execute some custom commands based on its previous response, and it will try to correct itself. So it found some issue, it has done some debugging, and it was able to execute the right command. So and that's why it was executing so many commands. So this is how it can execute the script. Next is permissions. So how we can define permissions for some skills files, some memory files. So again, same program. I have created two folders here, shared and personals. Okay, and I'm creating uh, I'm creating this directory. Okay, I'm copying the data, commit message style and commit message. I've copied it at two places. Now you can see, again, I'm creating the agent, but here there's a permissions I have defined, and how we are defining a permissions. So we have already seen that first we have to define the deny mode, and then we have to define allow mode, and in the path we can pass regex. So here in the deny mode, I'm using skills shared, and it is in the deny mode. We cannot write it. So write mode is denied. So file system permission takes three parameters: operations, path, and mode. Operation can be read and write. Mode is anyway allow or deny, and path is going to be list of regex or path or globe. So I have defined the deny and allow mode. So what it is telling that in the shared we cannot write it. In the personal we can read and write, but in shared only we can only read it. And in the instruction I am telling write at the both places. So ideally it first one should throw error, but in the personal it should be able to write it. Okay. So let's run it. So it has printed this is something Python is printing. It is not coming, it is coming from here. So in the skills and shared, deny write, allow read, and the skill and personal, allow read and write. So in this folder, we should have read and write permission. So let's check the agent's output. Okay, okay. So it has given this message. See, attempt to edit this one, skills.md shared, error, permission denied. It was not able to edit that. But if you see the second one saved to, sorry, the third one, commit message, attempt, and the third one, third step, skills personal note. So here operation succeed. So it was able to write in the this personal memory or personal skills. So it was able to write in this skills file. So you can also control the permission set. Okay. Now you can combine skills and memory together. So in this demo, we are going to see how we can combine skills and memory together. So again, I'm loading the env file, root directory, skills directory, and user ID. Here I'm using the user ID. I'll see. Now, how I'm creating agent here. So I have created composite backend here. Why I've created composite backend? So one is for skill and one is for memory. So skills are going to be loaded from our file system. So that's why we have file system backend. And memory, I'm again using in memory store. So that's why I have in memory store. And this is the default one is file system backend. Unless until we have this memory route, it will not be triggered. So I have created two routes, and that's why we have composite backend. Now, if you see the instruction system prompt, so I'm asking use the commit message style skills, which has already present in our folder. And before writing a commit message, check memory preference.txt, personal formatting preference the user have saved, blah, blah, blah. But the important part is here. When I'm creating agent, what is the instruction I'm passing? So an instruction I'm passing that I'm asking that load this preference txt, and I'm saying that create a different kind of uh, formatting styles. I always want to scope billing. This is a new one, and reference TBD. So this is a different kind of instruction or formatting instruction I'm giving. Okay. Now in the session two, basic, I'm creating another agent, and then I'm saying write a commit message for this change, and I'm creating this one. So in the one agent is updating the memory file, and second agent is loading that memory file along with the skills, and then it is trying to use that. So let's run it. So okay, again let me clear it. So we have loaded the memory, we have loaded the skills file, we have loaded the memory file, and then we have combined it together so that memory file and skills file can update the formatting output. Okay, and if you see the output commit message here. So it is not different from what it was present in the skills because based on the memory, it has updated itself. So first it has saved the memory, then it has loaded the skill, and then based on the memory, it has updated the formatting of, instruction. So you can see now we have one new thing called billing, which was not part of our commit message. If you see here, this.md, we don't have this one. But since it was present in the previous instruction, it was able to add it. So this way we can manage memory and skills. Hope it makes sense.